50 to 100,000 light years across. The solar system is, well, from the Earth to the Sun is only 8 light minutes. This is 100,000 light years that the gravity is extending even over these distances. And in the next slide is evidence that it extends even further. Here is what is called a cluster of galaxies. There's a galaxy here and here and here. There are galaxies here. They're all in one lump of galaxies, analogous to the cluster of stars, but this time what's clustered are those big babies that I showed you in this previous slide. Now this is as far as, it's about 1/10, or well, 100th maybe, of the size of the universe, and as far as we have any direct evidence that gravitational forces extend. So the Earth's gravitation, if we take the view, has no edge, as you may read in the newspapers, when the planet gets outside the field of the gravitation. It keeps on going, ever weaker and weaker, inversely as the square of the distance, dividing by 4 each time you're twice as far away, until it mingles with the strong fields and gets lost in the confusion of the strong fields of other stars, but altogether with the stars in its neighborhood pulls the other stars to form the galaxy, and altogether they pull on other galaxies to make a pattern, a cluster of galaxies. So the Earth's gravitational field never ends, but peters out very slowly in a precise and careful law, probably to the edges of the universe. The law of gravitation is different than many of the other, well, is very important in the economy or in the machinery of the universe. There are many places where gravity has its practical applications as far as the universe is concerned. But atypically, among all the other laws of physics, gravitation has relatively few practical applications. I mean, the new knowledge of the law, it has a lot of applications. It keeps people in their seats and so on. But it has few, the knowledge of the law has few practical applications, relatively speaking, compared to the other laws. This is one case in which I picked an atypical example. It is impossible, by the way, by picking one example of anything, to avoid picking one which is atypical in some sense. That's the wonder of the world. The only applications I could think of were first in some geophysical prospecting, in predicting the tides, nowadays, more modernly, in working out the motions of the satellites and planet probes and so on that we send up, and also modernly to calculate the predictions of the planet's position, which have great utility for astrologers to publish their predictions and horoscopes in the magazines. That's the strange world we live in, that all the advances in understanding are used only to continue the nonsense which has existed for 2,000 years. Now, that shows that gravitation extends to the great distances, but Newton said that everything attracted everything else. Do I attract you? Excuse me, do I attract you? I was going to say, excuse me, do I attract you physically? I didn't mean that. What I mean is, is it really true that two things attract each other? Can we make a direct test and not just wait for the planets and look at the planets to see if they attract each other? And this experiment, the direct test, was made by Cavendish on equipment which you see indicated on the next slide. If I got my slides right. Well, I made a mistake. I was talking about the importance of the gravitation. I was overwhelmed by my clever remark about astrologers and forgot to mention the important places where gravitation does have some real effect in the behavior of the universe. And one of the interesting ones is the formation of new stars. In this picture, which is a gaseous nebula inside our own galaxy, and there's not a lot of stars, but it's gas, there are places where the gas has been compressed or attracted to itself here. It starts perhaps by some kind of shock waves to get collected, but the remainder of the phenomenon is that gravitation pulls the cloud of gas closer and closer together. So big mobs of gas and dust collect and form balls, which as they fall still further, the heat generated by the falling lights them up and they become stars. And we have in the next slide some evidence of the creation of new stars. It is unfortunately harder to see than I thought it was when I looked at a